So I'm just going to hand it over in a few minutes to Dr. Joshua Chou from University of Technology. Josh is working in the, I think your proper title is you're a biomedical engineer.
Yeah, I guess that's a good title.
That's how I see your qualifications. You're actually going to be talking about medicine in space and survival. And you've been over there for a few years, but I recall last year you won a prestigious award from the Space Awards.
Oh, yes, I did.
So, yeah, we actually had two of our participants recently who we get the next month's speaker actually won the Scientist of the Year, and Eva Cairns, who did his talk last month about Quavasat, he got an award too.
Oh.
So that was, so we do have some award-winning people who will speak for us at times. So Josh is going to be talking about the survival in space, I suppose you could say, in the biomedical aspects. And I will now turn it over to you, Josh, to tell us about these things, which is very pressing because we all need to think about surviving in space if we want to go to Mars.
Absolutely. Thank you again, Wayne, for giving me the opportunity to come, share with everyone my research. I have to say I'm just recovering from a cold, so I might cough here and there, so pardon me. So as the title suggests, my talk is about surviving and thriving in space, and I think for a very long time, we focus on the technology aspect of space, I suppose. And I think the human element has been neglected quite a bit. But fortunately, this is picking back up. So today, I just really want to give everyone insight of what we do in my lab, the type of research, and also some of the products we're developing in support of the human element in surviving and thriving in space. Oh no. Okay, here we go. So just want to quickly introduce everyone to give you guys a little bit background about myself. So I did all my bachelor, PhD, my first postdoc at UTS. I was very fortunate to go to Japan for my second postdoc, and then I went to Harvard, which will also tie into the story later. So I came back to Australia, back to UTS in 2017. Where I started my own research lab. So we deal with a lot of I guess different aspects of this type of cell mechanobiology research. They might look very, I guess, independent individually, but they actually all tie together in terms of what they do and so on. I've also been very fortunate to be part of the Australian Space Agency Space Medicine Life Science Committee. So we are trying to put the roadmap of what the next 5 to 10 years will look like in terms of Australia's space medicine and life science. So there are a lot of exciting things happening in Australia, being spearheaded and led by Australian researchers and academics and so on. So I think this is going to be a research focus and a very important pillar in the coming years. So I think like most people, I started off this with being a sci-fi geek as well. I love my sci-fi collection. I think I presented this once, and one of the audience actually took note of all my sci-fi collection. So I'm pretty confident that most people would have seen one or if not all of these. This also probably reflect how old I am as well, given my taste in sci-fi movies. So we all know right now, we have this aspiration from NASA of wanting to go to Mars, going to the moon, going to Mars, and I really like this image because it really depict what is actually involved, the complexity of it, and there's still quite a bit of way to go before we are able to achieve that. So this next image here, it really summarizes some of the key and core technologies that we need to, I guess, master before we can even think about sending humans to whether it be the moon or Mars. And these technology, obviously we're talking about medical technology, 3D printing technology, because I think it's accepted that it is a much more convenient way of producing, whether it be surgical tools or even just general tools to biomedical appliances. So there is a lot of element that needs to be put into consideration, because if there was a medical emergency, whether it be on the moon or Mars, help is not really going to come really fast. So with the moon, you can probably get back within a reasonable time frame. I think it was about 7 days. But Mars, there's no return trip, so to speak, for now. So as everyone is aware, the Artemis project is obviously at the forefront of space advancement, and obviously that requires wanting to put people back on the moon in the first instance, and then of course over to Mars. So I think our first challenge is how do we actually survive on the moon, and then we can go on to Mars. So I think, a lot of us have childhood dreams of wanting to go into space, myself included. But I think, as a child, we have this dream of going to space, but that dream is actually going to become a reality. So, whether it be, not only going out into space, but, visiting different stars or different planets, or even living amongst, in space. So everyone would have heard about the ambition to have a space hotel in the next couple of years. So, this is not only science fiction or dream anymore, it's a reality. It's a matter of if, and not, it's a matter of when, not if. So this really puts into kind of perspective and sets up background for what I do, which is, space biology. And that's really to, complement, enabling exploration for longer and deeper space missions, making new discoveries, and of course, the double complementing thing we can do is improving life here on Earth, because a lot of the technology understanding is actually very translatable. And I think that's what really drew me to this area of research. So if you think about life on Earth, gravity really shapes life here on Earth and in space. So gravity really affects, the human body, not only from a whole person level. It starts at the cellular molecular level, and because of that influence, it influences the tissue organ level, and obviously to the whole physiology level. So gravity takes a very important role. And I think for a very long time, we all accept that, there's a negative effect to space, but no one really understood how, why, or, what's actually happening. We know what's happening on obviously the whole person level. We know somewhat at the tissue organ level. We know things start to deteriorate, but we really lack knowledge on the molecular and cellular level. So of course, as everyone is well aware, there are medical challenges for spaceflight, and this is even more true for space tourism, whether you're going up on Blue Origin or Virgin Galactic or other companies. These are nevertheless challenges. So obviously now missions to Mars won't take several years. I think it's a lot faster now. But having said that, it is still a relatively long journey when you take into context the human body that has to withstand it. So it's not like we haven't done much in terms of space biology or space medicine. We have done quite a lot. And as I mentioned before, our understanding predominantly remains at that, tissue and organ level. So we know, the different types of space flight, the duration of the space flight, some of the short-term and long-term medical challenges, but you can definitely see that they all correlate to microgravity and radiation. So those are your obvious two environmental factors that really affects the body. So you can see in this summary, it depicts all the different changes. So basically, space, as romantic as it is, it's not built or meant for human beings to be there for a long time. So it means we have to find countermeasures and protections for us to be able to conduct longer and deeper missions in space. So as I just kind of mentioned, once the human body gets to space, you're talking about a lot of different factors. Again, radiation, microgravity is obviously at the core of that. Then you have your cosmic rays, bursts of radiation, magnetic fields, and so on. So, the effects we're seeing, is it purely microgravity? Is it purely radiation? Is it a combination of both? And, those are simple questions that we really don't have an understanding or grasp of, how it affects the body. So for me, if you don't understand how it affects you, you can't build countermeasures or protection against something you don't understand. We might guess on what it might be, but that still remains just a guess. So what is microgravity, and how does it have such a profound impact on the human body? So I think everyone can appreciate that as we lived throughout human history, the weather has changed, the geography has changed, animals, humans have changed as well. But the one thing that hasn't changed is really gravity. So our whether it be us, animals, bacteria, viruses, they don't have any genetic memory of not having gravity. So when they're exposed to microgravity for the first time, they start to react really differently. And I think that's what's really amazing, because there's no recollection of that. And so that's why it is a very interesting environment that we can leverage and use to our advantage. And whether it be biomedical research, fundamental science, and of course various space exploration and commercialization. So as I mentioned before, the problems we see in space has also the same problem we see here on Earth in terms of the type of disease conditions. So if you in all simplicity, space accelerate disease condition. This is good and bad. Of course, it's bad for the person that is out in space. It's good for researchers like myself because it can help us accelerate biomedical research. So this here kind of lists out the types of diseases that is similar to on Earth, and you can everyone obviously know bone loss is associated with microgravity, so that's obviously a big one. So there has been a lot, because there's no point flying all the way to Mars if you end up getting there and you're all wobbly because you have no more bones left. Your bone structure is your fundamental organ to keep you functioning, so to speak. So let's have a look at bone. And people ask me this. This is a picture of me, so I just want to clarify that this is me behind. This is the shirt. It's a joke. I don't look like that. I wish I did, but I don't. So I want to introduce to everyone the concept of mechanical loading, because this sets the foundation for what I'm talking about here tonight. So we all know that we should exercise, go to the gym, lift those weights to really build muscles and so on, and that exercise is good for you. We all know that. But now we finally come to understanding what's actually happening at the cellular level that actually makes exercise good for you. So if you think about the importance of exercise is good for you in terms of mechanical loading, then that also means the opposite, mechanical unloading, is bad for you, which is where microgravity really fits in. So we know that the bone density loss per month during spaceflight is quite substantial. It's 1%. So the longer you stay out there, the more significant the impact is. So that's kind of setting up the understanding of how microgravity affect your body and what we can do about it. So a lot of people when I talk to introduce people to microgravity, I'm sorry, mechanobiology, what does it mean? Mechanobiology is a new term that scientists would use in the recent years, but it has been around for a long time. So whether it be braces, we know that it uses applied forces to move your teeth, whether it be exercise, or I'm pretty sure everyone enjoys a nice massage. It makes us feel good. So this is already something that we do, and it's already existing in our life. It's just that now we actually have a name and a terminology for it. So if that is true from the whole body level, what's actually happening at the cellular level? So you can have a look here in terms of mechanobiology, the stiffness of the different organs in your body. So you can see over here in bone. Bone is obviously very tough and stiff. And of course, as you go down to mucus, brain, lung, liver, muscle, it has a different stiffness. Different stiffness when your cell also means that your cell is also reacting differently on those different types of stiffness. So one of the key concepts we have to understand with bone and osteoporosis is that this is a picture showing a normal bone porosity. And when you get osteoporosis, we all know that you lose bone density. So one of the main concept with bone is that we all understand osteoporosis really comes about with the onset of an imbalance between bone formation and bone destruction. In the bone field, only in the last, I would say, 8 to 10 years, we started to identify a new cell called osteocytes. And osteocytes has been termed the orchestrator of bone remodeling. So if you think about a construction building, your osteoblast builds the bone, so they're the builders. Your osteoclasts destroy the bone, which is your demolition people. Your osteocytes is the manager, basically your project manager, that dictates how much of the building gets built and how much of it gets destroyed. So osteocytes has become a very key and important cell that bone researchers have been focusing on. So, again, this really summarizes, what happens about the imbalance I was talking to you about, where you have to have a balance of build and destroy, but then osteoporosis and vice versa, that's an imbalance of what's happening. So you're probably thinking like, why am I introducing these terms? Because this obviously has significant implications for astronauts who lose a lot of bone. So how did I actually discover osteocytes and its mechanosensory function? So there's actually a condition. As you can see, this is a very classic example of a patient suffering from bone overgrowth. You can see his forehead has significant overgrowth of bone. And that's when they actually realized that his osteocytes, which secretes a compound called sclerostin, is actually very active. So sclerostin is actually inhibits osteoblasts, it inhibits bone formation. So if you have more sclerostin, it's actually really, really bad. So once they discovered sclerostin in 2001, researchers start to look deeply into it. So this really sets the stage of how I got involved in space biology research, because during my time over at Harvard, I was one of the group I worked with NASA and Amgen in the development of the sclerostin antibody. So the sclerostin antibody was injected into rats before going to the ISS. And what was really cool about it was that not only did it prevent bone loss, it actually increased bone loss. So in short, what that means is the sclerostin antibody basically blocks sclerostin, and that will fool your body into thinking that you're exercising when you're really not. So it's actually activating bone formation constantly, so that you can trick the body into continuously making bone without suffering the effects of microgravity. So this has since been released as an osteoporotic drug here down on Earth. And I think, I always use this as a very classic example of, how we can use space to not only solve problems in space, but also solve problems down here on Earth. And I think that's very beautiful that we're able to do that. So it's all good and handy that we can do these research up on the ISS, but we can't all afford or have the ability to all do research up on ISS. So what can we do here on Earth? How can we do research or set up the foundation or hypothesis before we actually commit to a research mission on the ISS? Because recently I did my mission. It was launched a few weeks ago on SpaceX 22, and I can say it took a very long time. Not to mention, it also costs a lot of money. So we have to be able to ensure the experimental question we're asking is actually on point. So down here on Earth, there are different ways that we can mimic or recreate that microgravity environment. Whether it be magnetic levitation, parabolic flight and drop towers, neutral buoyancy, and random positioning machine. Now, the problem with a lot of these is that, well, it induces microgravity. It doesn't induce it long enough to see a cellular effect, so with the exception of the random positioning machine. So this is what a random positioning machine looks like. You can see that there are really big ones where it actually rotates and shakes the incubator with the cells inside it. There's obviously a really massive one. This one was made by Airbus for cellular studies, but that has since been discontinued. So really there isn't really that much options out there. And you can see a lot of these were created by engineers and not really by with the input of biologists or researchers. But they work perfectly from an engineering perspective, I suppose. But really what we need as biologists is, something that caters for what our needs are. And, there are a lot of things that we have to be able to capture or develop along the way. So when I came back to Australia, I really wanted something that I can use for my research. There was nothing on the market, so then I decided to create my own. So we had a spin out company in which we've made our own RPM, and you can see that if it really caters for basically what I need for biologists, and we've been very fortunate that we've been able to work with ANSTO to conduct experiments with radiation. So our platform is really now evolved and advanced quite a bit to cater all different types of cell biology and disease studies. So one of the initial projects that I started on was looking at the effect of microgravity on cancer. And one of the more mature cancers that we've looked at is breast cancer. So this one's going to come out in publication in a couple of weeks' time, and we have other cancers as well. So, people ask me, like, why did you start with cancer? Like, of all the things that you can start with. And really because cancers are highly mechanosensitive. And when I started, it was just really for fun. I wanted to see what happened to them. And it turns out they affect them quite significantly. So you can see here during the different time, the control cells, the control breast cancer cells, they grow perfectly fine. But you can see that in the RPM, in the simulated microgravity, over time, they start to disappear quite significantly. And you can obviously see that the cells are much more rounded. Initially, we thought, there's a significant reduction in the cancer cells. Is it because they're dead? What we found out was that the ones that came off or flowed off actually weren't dead. They just kind of detached. So that was very interesting. So we kind of looked at that phenomenon a little bit more. So what we did was we took those cells that kind of flew off and then put them back into gravity. And what we found was that after 3 days, the cancer cells were able to readapt to gravity. So you can see here after reattachment. So we did a whole profile analysis on the cancer cells, and it shows that they regained their full capabilities after 3 days back here on Earth. This is very interesting because astronauts, when they're going to the ISS, it takes about 2 to 3 days before they start to feel the impact of microgravity. Similarly, when they return to Earth, it's the 48 to 72 hours as well. So there's some magic happening between that time for readaptation. But this also shows that the cells are able to readapt, which fits into the logic of humans or readapting to space and back here on Earth. So what we've looked into now is looking into if the cancer cells can have genetic memory of being in microgravity, and if so, can they adapt to it better the second time? So the analogy I like to give to people is, asking you to stand on a waterbed for the first time. You're going to fall off the first couple of times, but as you get more used to it, your body knows how to compensate for it. So we really want to understand if cancer has that capability or not. So it's actually quite interesting, and the results that we're getting. So this is just some of the, the results we got to really show that, microgravity does impact on the breast cancer cell function and migration. So you can see here at 0 hour, this is basically a free area zone. The cells are on both sides. And in 24 hours, you can see this cancer has been migrating towards each other, whereas the microgravity, that migration has been significantly impaired. Sorry. So, we see this not only in breast cancer, we see it in 5 other types of cancer. And, people ask me, like, why are you looking at all the different cancers? And, what is the pattern between them? So the best way I can explain this is that, for example, in this room right now, we have 17 people. We're all very different people. We're different ages, with both different ethnicity, different in many different ways. That's like cancer as well. There are different types of cancer, and every single one of them reacts differently. They do different function. They invade differently, but there must be some basic function that they preserve for existence and survival. Same as us. We need to eat. We need to breathe air. We need to sleep. We have heart rates, that so on. So we have basic survival instinct. And my hypothesis was that cancer's basic survival mechanism can be disrupted in microgravity. So people ask me, like, so what? Your idea is to send a bunch of cancer patients into space and hopefully they'll get cured, and that's really not the intention. The intention is very similar to sclerostin. How do we find those mechanosensitive receptors and targets that we can trick the cancer to think it's in space, but it's actually here on Earth? So what we did was really, screen all the anti-cancer drugs available on the market, and you can see that in the bottom 3, there are 3 targets or 3 drugs that are currently on the market that are available that would suggest that it's reactive to microgravity, to the effects of microgravity. So I always tell people my goal is not to find some magic bullet to cure cancer, but really it's to see how can we complement or how do we increase the current efficiency of anti-cancer drug. Because if you really think about it, it's microgravity is really disrupting its mechanism. So if it's busy trying to find its way to survive, that means that we can increase the therapeutic effects of current therapy or drugs that are available. So we're able to show and prove that. So that's very encouraging and very exciting for us. As I mentioned before, and I don't have time tonight to show you all the different cancer results we have, but this is one of our latest one. We look at brain tumor. Brain tumors are one of the hardest cancers to fight because you have your blood-brain barrier that protects your brain. So any medication, it actually gets blocked out from the actual brain area. So it really limits the effectiveness of anti-cancer drug. We're very fortunate to be funded by the Charlie Teo Foundation for this research, in which we use microgravity to open up the blood-brain barrier so we can increase the amount of anti-cancer drug for brain treatment. This is a really beautiful picture showing, so this is what we call a tumor spheroid. You can see in gravity, they form all the cancer come together to form a tumor, but you can see under microgravity, they lose that ability. So it really significantly disrupt their ability to form a tumor in the first instance. So what we're looking at right now is that, okay, we can disrupt the initial cancer from forming a tumor in the first instance, but what about established tumors? Can we disrupt those type of cells as well? So those are ongoing research that we're looking at right now. So a lot of people, they ask me, so what does this mean for the everyday person? Does it have a real world implication, or is it something that's just fun facts for researchers? And I say that there is definitely real world application. So in terms of cell bioreactors. So for those people who aren't really familiar with bioreactors, basically these are bucket chemistry where they use cells and they harvest a lot of their growth factors for the everyday pharmaceutics. So these are just real big tanks of cell. So if you really think about it, the microgravity device that I just showed you, it's essentially a bioreactor in a different way. So we see a lot of potential for cell manufacturing. And we have other projects where it's a bit more confidential, in which we see a market value in harvesting large quantity of cells under microgravity. So the other one was float therapy. I'm not sure how many of you guys have tried float therapy. Before a very long time, I didn't try it. but because of my research, a few people has contacted me and said, flow therapy has been said to be equivalent to microgravity, and they asked me if that can actually help with their cancer. As a researcher, of course, I can't say it can or cannot because there's no studies ever done on it. But it was interesting to know of the 4 people that contacted me afterwards, they went on flow therapy for 6 months. Their cancer actually disappeared. The doctors don't know why or how. But again, I say that's only 4 people. It's not very scientific. But having said that, I went and tried it myself. I absolutely love it. So if you guys are like me, always stressed out, I would encourage you to give it a go. It really helps with de-stressing. So going back to what I was saying about the positive effects. So everyone's fixated on this negative effects of microgravity, and it is true. Long exposure to microgravity does have significant impact on the body, but no one's really talked about the positive impact. And whenever I talk about positive impact, people are like, what are you talking about? So when I say positive impact, I'm talking about short-term duration exposure to microgravity and the impact it has. So the way I explain it is, it's like, those people who, winter swim in the frozen lakes, and then it boosts their immunity. You going to the exercise, having those, weights on you. Those are extreme environments that pushes your body at the cellular level, making your cells work harder to compensate for it. So in essence, microgravity is one of those extreme environments in which it can force the cell into trying to compensate for it. It's a very short period of time exposure to have those positive effects, but nevertheless, we have shown and demonstrated that we can achieve those positive effects. So without saying too much, we have shown that it can help in regeneration of different tissues and organs inside the body. So right now we're just trying to find ways to mass produce this so that everyone can benefit from it. So I want to really share that there is real world implication from all the cellular, starting at the cellular level and moving our way up to the tissue organ to the whole body level. So I guess it comes down to where do I see opportunities in terms of space medicine. And as you can see from this diagram, a lot of people has focused on launches, rockets, satellites, and so on. That's all great, and we definitely need that. But that's kind of comparable to Amazon being a very successful business. Amazon don't make their money by developing delivery trucks. Nevertheless, delivery trucks are important and integral to their business model. But nevertheless, they don't rely on the delivery trucks to make money. They make their money from the services they provide. And that's kind of where we're focusing on, is developing the next upcoming and next generation services that's related to space health and medicine. So on that note, as I mentioned before, I started a company called EXPLOR, microgravity, and we are anticipating the rise of space tourism and people going to space. So we've developed a range of products and services to look after you before, during, and when you come back to Earth. How that impacts your body, and are you able to go into space in the first instance, and if so, how long can you do it for? So there's still a bit of gap in terms of space tourism. We know people want to go into space. Some people can afford it and so on, but no one's really discussing about the health impact of it, how that affects you, and how it affects you when you get back to Earth, because we know it does affect you. So apart from that service, my company also has a suite of other, technologies. As I mentioned, the performance suit, we have robotics, the biological pharmaceutical CubeSat, and more recently, mental health as well. We all acknowledge that for astronauts, especially astronauts, mental health is a very big issue that no one really talks about. We've identified this as part of our committee as well. So I've been very fortunate to partner with a few very nice companies in the world to really help in this space. So, I just want to really show everyone that, to do this type of research, I cannot possibly do it by myself. And it really takes a global, they say it takes a village to raise a child. It really does. And I've been very fortunate to, work with, world leading institutions, both here and abroad, to make a lot of these research happen. I just put this here as a teaser because we're about to make a very large announcement in the upcoming weeks with myself and my company with a lunar project going back next year. And finally, I host the annual Australian Space Biology Symposium. This year we have a Biology and Health Summit. So it's in November, it's free. So if this is something of interest to everyone, please feel free to register, come and hear our talk. We've been very fortunate to be supported by all the different space agencies. And it's not only focused on just biology and health, it's everything that supports the biology and health. So, we have talks from space ramen to, space fashion week and so on. The website's not up yet. It'll be up in the next week or so. So yeah, I think that's all I got today. I hope that was interesting for everyone. And I guess we're open for questions.
Thank you very much, Josh. Can you actually see the questions, or do you want me to read them out to you?
Let me have a.
You have to go to chat.
Oh, no, yep, I find it. Okay.
Yeah, we'll talk after that. Well, these are the ones that have just been asked while you've been speaking, but I think we'll probably have a couple more, I'd say, after you.
Okay.
Thanks.
So the first question, I think it's from Janine.
Yeah.
What has greater impact, microgravity and how is it? Okay. Okay, so her question was, which one has greater impact, the microgravity or radiation? And I think there is no clear answer right now. And that's why we've, developed, we need the tools to be able to answer these questions. So that's why we've, worked with ANSTO to establish this, I guess, this new equipment, hybrid equipment, in which we can expose radiation and microgravity at the same time to really, filter out exactly your question. Is the microgravity impacting? Is it the radiation alone, or is it a combination? And so it's exactly what we're doing now is what you're asking is we're looking at, not only at cells and diseases, but also, food, pharmaceutics, because we all understand pharmaceutics can be impacted by radiation and microgravity to have different function or not functioning at all in space as opposed to Earth. So hopefully that answers your question. Your next question when you return. Okay, so your next question is about when you return, if you have triggered that bone density process, is it easy to stop by ceasing medication? Yes, it is. So that medication, the sclerostin antibody, so that doesn't have unlimited effects. So it's something that you need to take, once every few months. So the effects does wear off over time. So that's really not, it's not never-ending thing. Sorry. Oh, Wayne's question about ANSTO. Yes, we've actually have installed our equipments, and we have groups of students that goes there. It's not the closest place on the planet, so it is a bit of travel, but we do have established team over there to do that research. What are the characteristics of your health spacesuit?
You actually flashed past to that slide, some interesting things about the suit. I wonder if you could show us that slide again. I'd like to catch the last couple. I didn't quite catch it.
Oh, this one?
The one, yeah, robotics, yep, and mental health. Yeah, the space performance suit. Yeah, that's the one.
Yeah, so we really wanted a different approach in terms of how we approach the spacesuit. It's not meant to be like those EVA suits where you go out. It's really catered for space tourists or astronauts inside the space station. So we took on the mentality of if we were paying $250,000 to go up into space, we obviously want to take a lot of Instagram photos and look good and feel good. So we were very fortunate to work with Christian Dior and Louis Vuitton. We have worked with the designers, and that's actually Christian Dior fabric, which they supported us to really bring a different dimensions to the meaning of spacesuit. I think that's an element that has been really missed out, an opportunity missed out in terms of spacesuit design, because I mean, I think right now SpaceX has probably the better looking suit, I suppose. But having said that, there's not much in terms of what's underneath the suit. So that suit looks really empty, but underneath it is a lot of technology. And what I mean by technology is, it monitors a lot of different vitals. And again, I want to say is, detecting vitals is not hard. These days you can buy that from any electronics store and kind of clip it on. But what we bring to the table is the platform behind after detecting those vitals. So we have AI programs in which we can help detect what is the anomaly and how that can affect in the individual's health. So we see that as a very impactful and very important factor. And we again we partner with the likes of Amazon and Google because they're also very interested in the health data. So the more data we capture of people going to space, the better informed we can be of how to protect ourselves in space. Because let's face it, there's not that many astronauts that's been into space, let alone women in space. That's definitely not a lot there. So there's a very big gap and niche, and especially in women's health in space. We're talking about like even the simple question of periods, how it impacts it. Like no one has really talked about it. And female astronauts generally go into space just eating the pill, so they cut off periods altogether. So how does it impact them? No one's really looked into it. So I'm very happy and excited that I've actually started having a couple of students to look at what are the effects of microgravity on female health. And I think it comes very timely because we can't just send men into space. More women are going to space, and we have to be able to at least know how it affects them, and so that we can better protect them. And the next question is, have you come across anything to help with cartilage loss in osteoarthritis? That's a very good question. We literally embarked on a project on that. It's actually been supported by the US Space Force. So we have started on that. It's actually very complex because osteoarthritis has always been, we know what it does, but we don't know how it works mechanistically. So this is exactly the question that the US Space Force want us to answer. So hopefully in 2 years' time, I'll be able to share some of those results with you. Hopefully we find out a better solution as well.
The discovery of the osteocytes was very significant, obviously. So
yeah,
like that'll be found for cartilage.
Absolutely. So we definitely see that as a critical problem that we want to address both in space and here on Earth. So will space tourists be participating in research as willing guinea pigs? Well, I guess we're not forcing them to be tourists, so it's completely optional. But I think it is also in their best interest to see how they are affected by their trip, even though it might be short. Everyone responds differently. It's just like like anything else. Everyone responds differently. It's like if I put you in Antarctica, everyone will respond differently to that as well. So we just offering a way for people who do go. We can help with that kind of monitoring. Whether you want it or not is completely optional. But given that you pay so much money, you probably want to know what's happening as well.
I would think most tourists would be happy to contribute any way they can.
Exactly. Exactly. I think if you were going to pay that much money to go into space, I'm pretty sure you want to also be able to contribute to that research of humanity being in space. So Janine's next question was, wealthy space tourists are likely to be older and on medication. So has Big Pharma been checking the efficacy of medication given blood and blue? No, to the best of my knowledge, no one has really looked at that. And that's why I say it's very important to actually ask these questions and have these discussions before you start jetting people off into space. I don't know how insurance work for space tourists. I presume there's a big thick waiver that you have to sign before you go. But again, these are fundamental questions we think we have the answers to, but as far as I know, no one really knows that. That's why we have embarked on research on pharmaceutics, medication formulations, because no one really have the answers to these really what I consider basic questions. So that's why I started the symposium, is to really bring the world together, because I cannot possibly do everything, and I really want to unify everyone to come together to answer some of these fundamental questions. And a lot of businesses also, we want to promote how do you take your business and transition into the space economy. And a lot of people don't think they have a way that they can contribute, but they actually have a lot to offer. Even the simple things of moisturizers. When you're in space, your skin actually gets very dry. So how do we actually address that? So there's actually still quite a lot that needs to be done that we haven't really looked into. But yeah, so we're just trying to see what we can do and contribute to that impact. I can imagine EpiPen disaster. I can too. So there's bound to be something that goes wrong, but no one wants to be that first person. But again, we can try to, I guess or simulate as much as we want. But at the end of the day, we have to be ready for the unknown. So the more research we can do down here, the better informed or prepared we can be up there as well.
Yeah, you were talking about counter pressure suits earlier, Josh. I think I remember Dr. David Newman from MIT's done a lot of research on those particular ones for Mars.
Yeah. So yes, I have looked into their technology. We've kind of took a different way in terms of the counter pressure. But yeah, that's kind of in our IP right now, so I can't share too much on that.
No, I can understand that at the moment until you get to a point where you can kind of start the licensing sorted and get all that side sorted out. But the good news for you at the moment is that with the space tourists and also with going back to the moon, probably within about 4 or 5 years, there's going to be a lot more opportunities to do research because of the fact that there's a lot more. I think we may have 2 companies operating by the end of this year, potentially. That's both Virgin Galactic and New Shepard.
Yeah.
Both, and I think I remember seeing something announcement about a researcher going up shortly. I might be Virgin Galactic.
Yes, I saw her that she will be doing these health-related research. So everyone is catching on because these are realistic questions that we need to be able to answer. No one wants to send someone up there and having them die or having a heart attack or something.
And we also have the private space station, which is going to be run by Axiom. They've got an arrangement with NASA to actually attach some new modules to the station, but eventually I think they'd like to actually have a totally separate station. So there's now the opportunities for people to do private research as well, because they're actually going to be sponsoring that and potentially their own mission. So it's all happening at once, but it's going to get very exciting for that type of thing now, isn't it? So not like it was 5 or 6 years ago.
Absolutely, and like I said, everyone knows that there are these questions and these challenges, but so far there's been a lack of tools. So, we have to start off by making the tools to even do this research in space, whether it be private or public enterprises. So right now we're focusing on what we anticipate are the tools that is needed by researchers, so that we can help facilitate these type of research.
Okay, so there's a question from John here.
Oh,
come up. You see that?
Yes, and it's funny you mentioned that because both countries contacted me last week about this. So yes, I would say they are, and they're not only looking at in terms of space, they're also looking at very deep underwater. So if you think about microgravity, the opposite of that is hypergravity. So I know the Chinese and Russian are very vocal or very transparent in terms of what they do and what their research are. I've been very fortunate to have a rare glimpse of it, and I can say they're very, very advanced. And you can probably see that they just kind of randomly pop up on the news and say we're landing on Mars. So yes, they are doing very similar research. And like I said, this is not a problem only going to be faced by us. Anyone going into space will share similar problems. So it's a problem for everyone. So, they do see that there is a need to address these issues.
I believe the Russians have done a lot of work on space psychology, particularly because of all the long duration missions they did in the 90s. The US was actually behind them in terms of understanding the correct way for crew selections.
Yeah, yeah, absolutely. They are very intense in what they do, and they are doing also quite a lot in terms of radiation as well. So you know, but so Janine asked they have started mining tin from seabed in Malaysia, so can understand deep sea interest there. Oh, okay. Yeah. I mean, it's very cool. What they built, capturing really deep sea creatures and trying to understand them. I mean, some of these creatures look like aliens for all I know. So they've been doing quite a bit of that, and quite covertly, I guess, or very quietly over the last couple of years. So they're only able to do that because they've developed the tools to do that. So they've actually able to build one of the world's deepest submersible with robotic arms to capture these deep sea creatures to bring them back up to study.
Okay, so we got any more questions, folks?
Fantastic talk, Joshua. Thank you so much.
No, thank you for inviting me. Thank you.
It was a fantastic talk. I've learned quite a few things that we hadn't ever really touched before in terms of a speaker. So congratulations on your research, because it's relevant and importance in terms of, and also with the support you've been getting from various parties. I can see that that's why it's happening.
Yeah,
very relevant.